Okay, Mr. Evan here. We're going to continue with our renewable energy resources. First of all, let's take a quick look. We got energy for electricity, lighting, heating, agriculture, cooking, transportation, and industry. So we have it for quite a few reasons. Okay, so the nice thing about renewable energy resources, we have an unlimited supply. They replenish within a human generation. Some of them that's only true though if you have conservation techniques. And they tend to be clean, with the exception of biodiesel and ethanol, which are actually extremely dirty, just as bad as coal, perhaps. So the main ones are hydro, solar, wind, biomass, geothermal, and tidal. According to this graphic that I found on the internet, by 2050, there's supposed to be a huge mix of energy use. You can see what it looks like in this graphic, and you can download this note if you like. And they say for 40 years, there'll be jobs made by moving to renewables. Should create over 24 million jobs building and over 30 million jobs running renewables, according to this graphic. I don't know if it's true or not. That's just what I saw in the graphic. So next, let's take a look at the different kinds of renewable energy resources. So trees, biomass trees. If you use proper conservation techniques, it's renewable. If you don't, then it becomes non-renewable. So it's the oldest source of energy we've got. Recent archaeological finds in 2020 indicated humans have had fire for maybe 1 million years. It's a lot longer than we originally thought. And Canada was the first country to be carbon neutral for its pulp and paper industry around 2010. Any civilization that suffered deforestation quickly fell apart. So, for example, Easter Island. When people landed on that island around 1600, it was full of trees, 90% trees. And then eventually someone cut them all down. And by the time the Europeans showed up in the early to mid 1700s on Easter Sunday, there was nobody there, and all the trees were gone. If you take a look at Haiti, here's Haiti. See that? Hardly any trees. Here's the Dominican Republic. Lots of trees. When that island gets hit by a hurricane, Haiti or Haitian, devastated. Dominican Republic, they do all right. So it's pretty important to have trees. And the only way to maintain that is to make sure you have a good tree planting program. They also work as carbon sinks for fighting climate change. Okay, so the other biomass option is biodiesel and ethanol. So after the Gulf Wars 1 and 2, the United States, Canada, and other countries wanted to become more energy independent. This is before the invention of fracking. And so one of the ways they did that was diverting food to become fuel. So, for example, if you look at gas stations, it'll say on the gas pump that it may be up to 10% ethanol. And biodiesel is also being made for diesel vehicles. It's really bad, though, because it requires diesel or biodiesel to run the tractors. You grow the food. You got to use an expensive process to convert it into something you can burn, and then you burn it. So it's a triple whammy to the environment. It'd just be easier for the environment if you just got regular oil. Also, it has affected prices. So food prices in Mexico drove up after the U.S. started making biodiesel, and so now more people couldn't afford tortillas, and there was more malnutrition. One of the cool things about corn is they're actually using it to make biodegradable plastic, which is kind of cool. And ethanol plants have a bad history of causing health issues in the surrounding communities for some reason. Okay, so biomass methane. Now this is a good one, mainly from garbage and waste. And since methane molecules they hold over 10 times the amount of energy, and they have approximately 23 times more effect on climate change than carbon dioxide molecules, it's actually a good idea to burn them. It's the lesser of two evils. So you get a methane, some oxygen, you burn it, and it makes carbon dioxide and some water. So you definitely should be burning the methane. Germany is one of the leaders in using methane to make energy. Mexico also has landfills, and they collect the methane, and then they use it to run some of their buses. And at school, we use methane for our Bunsen burners. Okay, photovoltaic cells, or solar panels, or solar cells. They convert visible light into electricity. In fact, this was one of the few things This is one of the things Einstein discovered, sort of the only thing he ever got a Nobel Prize for. It's very inefficient, though, but in 2014 it finally became as cheap as coal if you lived in a poor country, like our developing nation. And there's some new technology where it's rollable, efficient, and it's pretty cool. It's revolutionizing things. So you got these solar panels which you can roll now. The efficiency's gone up a lot. If you take a look at the efficiencies here, 1954, we got a value of 6, all the way to record-breaking 2014, 46. That's an improvement from 74 to 2014 of 6.5 times more efficiency in just 40 years. So it's getting there. We're getting there. The other thing you can do, which is similar, is you can use solar systems that heat water in your roof, and then you basically get hot water. But that doesn't work too well in some countries like Canada. You got solar mirror arrays. So what you do here is you get a bunch of mirrors. You point them at a big vat of water in a tower somewhere. Heats it up to make steam, and similar to coal or nuclear power plants, that turns a turbine. Very popular in Spain and California. Okay, you got wind turbines. Okay, so sunlight heats up the air. That causes the prevailing winds, and that works the windmills and the wind turbines. The ancient Persians were using them around maybe 700 AD. The Chinese had them around 1200 AD. Windmills, that is. And then other countries are using them since. Norway tried to use offshore windmills, or wind turbines, in the 1990s, but it failed to be affordable. Germany started replacing their nuclear power plants after the Fukushima disaster in Japan in 2017. They're hoping to go 50% renewable energy through wind turbines. But like in Ontario, you got your NIMBY people, not in my backyard people. They don't want to see them. They don't want to hear them. I understand maybe the sound might be a little bit, you may not like that. But if you got a cottage and you see one out in the lake, they say, oh, that's ugly, they don't want to see it. I don't know. But there was an Ontario government study in 2014 that showed there are no health issues living near these giant windmills or wind turbines. Although some people do claim they do get sick from them, like headaches. Here's some designs. There's a serrated design based on whale skin, and with this, it reduces the radar signature, so it doesn't affect radar stations at airports. And unfortunately, birds do die with windmills. They run into windmills all the time. Eagles in Owen Sound, Ontario, had just started nesting again in Owen Sound. They put up a few wind turbines, and boom, next thing you know, eagles were gone. They found the bodies by the wind turbine. Hydroelectric dams. Sunlight evaporates the water, so this is really a form of solar energy as well. Rains, gravity pulls the earth down through the turbines and generators, so that's actual earth power or geopower. And the first hydroelectric dam ever was in Niagara Falls, shared between the United States and Canada in 1893. One of the biggest ones ever was the Hoover Dam one over by Las Vegas. The lake behind it is called Lake Mead. And that was built in 1931. And then finally, the largest one in the world is the Three Gorges Dam in China, built in 2012, where they flooded many villages and displaced hundreds of thousands of people. Here we got a fish ladder. So what happens here is the fish is able to climb up the ladder to from the bottom here to the top of the dam so they can migrate. It's very important in British Columbia where you have the salmon migration. And here you can see the old turbines turned by the falling water. Geothermal. If you go more than 3 meters deep in the ground, the temperature is pretty much the same, always around 17 degrees Celsius or 60 Fahrenheit. If you run your about 30 meters of pipe at that depth, you can pump it around and cool or heat a home. Or in some countries where you have hot springs, you can use the very hot water to power turbines. Only problem is you're probably living near a volcano when you do this. So Iceland's a great example. In China, when they built the Olympic Village in Beijing for 1996, they built pipes that actually went 500 feet underground, and they were able to keep the village at a nice temperature with very little use of other forms of technology. Iceland went 100% geothermal, but unfortunately there was the economic collapse in 2008, and it bankrupted the country. And then my cousin was telling me he has a system like this. He lives in the countryside, but his electrical bills for the pump are just crazy. So I don't know. They gotta maybe make that more efficient. We got ocean waves. Unfortunately, this isn't really being used very much. It's only being used in some countries where they hook it up to desalination machines using reverse osmosis to separate water and salt, for example, in Saudi Arabia or Kuwait. But this is great technology invented in Scotland in the 1970s. So as the buoy is going up and down, magnets pass by a coil, and that generates electricity. And that's it. That's all you need to do. They set up a system over in Liverpool, England, just a few years ago, but the buoys going up and down stole enough kinetic energy out of the waves they can no longer surf there. So poor surfers. My only question is, what do you do if you have a hurricane or something or a bad storm come by? But I'm sure they could figure out something for that. Then you got the ocean tides. The ocean tides, so the moon pulls the Earth's ocean around like this over here. So you can see the Earth's ocean is pulled towards the moon. And we get 2 tides a day because of this, approximately. And then here's a turbine over just off the coast of Canada. They tried this the first time, and the tides were so strong they ripped the fins right off the turbine. And the latest one they put out now has titanium fins, so hopefully that'll work. In Australia, they've tried something similar. They've got something called the dragon net, so the net rises up with the tide, locks into place, and then forces the water through the turbines at that point. So finally, we get into some newer technology besides the other renewables I mentioned. Something called a micronuclear fission plant. So nuclear meltdowns have been a problem, but these new technologies are safe. We don't have to worry about that anymore. So if you do choose to use the old uranium technology, what you would do is build your power plant offshore, and using the same technology for an offshore oil platform. And then what you do is at the bottom of the platform, you have some doors. So if there is a meltdown problem, you just open up the doors and the core just falls right into the ocean, where you won't have to worry about a meltdown occurring. And then I guess they probably assume they can use robots or something to recover the uranium at that point. That's not a very great option, but it's something you can do on the coast at least. But I like this one, the thorium MSR. So you got these molten salts with thorium providing nuclear fission, and that heats up to a great deal, but not so much that you have to worry about a meltdown. That's the nice thing. And it's scalable. You can build something about the size of a high school is all you would need, and you could power a city like the size of, with 150, 300,000 people. So it's just great. The only issue I find with this is security. If you have these small nuclear power plants everywhere, some terrorists with explosives would just blow that up, and you'd have a radioactive city. But you're not going to have to worry about any nuclear meltdowns anyway, which is kind of cool. Okay, clean coal capture and sequestration. So in this case here, you burn the coal, and the carbon dioxide, instead of going into the atmosphere, along with the other acid rain issues, you pump it down into an aquifer underground. Or if you're near the ocean, you pump it into the ocean. Right? And then that's it. You've captured the carbon dioxide. You don't have to worry about it. The only issue on land is if plate tectonics opens up some cracks in the ground and all that carbon dioxide comes out, then you'd stop working. And anyone in that area will drown in carbon dioxide. It's like a lithnic eruption. Very dangerous. There was a similar thing from a lake in the 1980s that killed a few thousand people in Africa. But the other thing you can do also is capture the carbon dioxide underground, pump it over to another location where you do some kind of chemical conversion. There's these new genetically altered bacteria and algae and these other processes that are being developed. So you can take the carbon dioxide and turn it into a reusable fuel source. So instead of getting more oil and gas out of the ground, we just take the carbon dioxide from our coal plant and we turn it into a fuel that we can use. So here's the holy grail of unlimited energy, which is clean: nuclear fusion. They've been saying for about 50 years now we're only 20 years away, but now they're pretty sure with our technology, computer modeling, and our leaps in technology that we should have it soon, maybe 5 to 10 years. So here's the three big ones. Laser fusion in California by Tay Technologies. They're using lasers to compress hydrogen together, tritium hydrogen, to make helium, and that's nuclear fusion, just like in a fusion bomb or in the sun. One of the issues before was, what do you do with the stray neutrons that escape, and then they end up making the whole wall radioactive and the whole building radioactive? They figured that out. You just line the wall with lithium, and it catches it, and you don't have to worry about it anymore. Then over here, this is the oldest type of technology we've been working on for a long time, called magnetic fusion. So it's got a donut shape or a toroid shape here. And the big ones right now is the international effort, ITER, in France. There's like 35 countries that have put money into that. And there's also one called MAST in the United Kingdom, which is pretty cool. And here's some pictures here you can see. My favorite one, though, is the one being done in Canada. This immigrant from India moved to Canada, and he came up with this piston form of nuclear fusion, and it's called General Atomics, and it's actually got some pretty big investors like the Bill Gates Foundation. I think maybe Elon Musk. I'm not sure. There's a few people investing in it, so it's pretty cool. And this one's scalable. Look at that. It's not that big. You can have a small one like this for every small city, and the nice thing is, yeah, you don't have to worry about any accidents. Even if someone did blow that up, all you do is just lose the fusion reactor. You'd have to build something else, but it's not going to irradiate the city or anything. It's perfectly safe. It's great. So that's it for the alternative energy sources and where we're working. Our next video will be on storage solutions.